Hi, my name is Chibun Kemoninania, and this is my charge tape lab. So this is the introduction. An electric force is the attraction or repelling force between two charged objects or particles. These may be negative, positive, or neutral. An electric force is caused by the electric field generated from that object and is dependent on not only charges but distance from the observational spot. The models used in this lab include Coulomb's law, electric force, and gravitational force. Coulomb's law and electric force are clearly relevant due to calculating the charges, and gravitational force assists us because the tapes were moved away from each other in the y direction. These forces assisted in the purpose of the lab, which is generating an observational and computational model to depict and calculate the electric charge on pieces of tape, which are acting as charged particles. The main results are the charge on the piece of tape is positive 5.6 times 10 to the negative 9. The gravitational force is negative 9 times 10 to the negative 4, and it is equal to the magnitude of the electric force, which is 9.8 times 10 to the negative 4. So the models I used were previously stated in the introduction, but essentially I used the electric force formula, gravitational force, and the two laws of attraction and repulsion. I also had the assumption that both pieces of tape have an equal magnitude in terms of charge due to their equal size and length. So the experiment consisted of sticking a piece of tape to another and ripping it off, thus creating a charged piece of tape. The tape should then be put over another and moved based on the charge. The initial conditions are the tape's mass, which is 0.002 kilograms, the tape's width, which is 0.01 meters, the length is 0.2 meters, and the force of gravity is negative 9.81 meters, and the distance between the two tapes is 0.017 meters. So this is my code. I'm just going to explain a small portion of it. Essentially, the first few lines were taken from the Lab Zero's instructions, basically. Phys is the 1 over 4 pi epsilon 0 constant, and then lines 4 through 7 were my initial conditions, which I just previously stated. Oh, that also includes line 8, I apologize, and I used a scale of 10. Now for line 11 and 12, which is one of the most important parts, I had to establish the force of gravity and the electric force. The force of gravity is mass times acceleration, and acceleration is negative 9.81. The electric force is the absolute value of the force of gravity because if you remember, as I stated earlier, the tapes moved in the y direction, meaning they moved in the direction of where the force of gravity is coming in, which is the y direction. And so, also in lines 17 through 20, basically I did the same thing, which is using the force of gravity. Basically, just I went ahead and updated the position vectors. In terms of color, I just picked random colors and I added lines 14, 28, and 29 so I'll be able to accurately see my data in terms of words. As you see, it says the gravitational forces, the magnitude of electric forces, and so on and so forth. So my observed charge using the formulas that I stated previously was 4.8 times 10 to the negative 9, while my computational charge on the piece of tape was 5.6 times 10 to the negative 9. The gravitational force and the electric force have the same magnitude, however, the gravitational force is in the negative y direction. So in conclusion, my observed charge once again is 4.8 times 10 to the negative 9, while the computational model was 5.6 times 10 to the negative 9, meaning my observed was close but a little off from the computational. The sources of error was likely due to rounding measurement using the meter stick during lab. Also, I had to use assumptions in the model, which could have led to an error, such as the assumption that the charges are equal in magnitude and distribution. So to answer the what if and why question, the what if, the magnitude of the charges should not change, only the sign. And to answer the why question, the more we handle charged objects, the more likely the tape will be attracted to our hand, thus losing its charge. And although our hand may be neutral, it has charged particles. This will affect the charge on the tape.